In this time of transformation, who do you trust? Only with trust can technology fulfill its potential and solve humanity's greatest challenge. DNV is shaping the future of assurance, helping our customers navigate these complex transformations with confidence. From the shipyard to the container, to the supply chains keeping industry moving, or the production, transport and transmission of energy, DNV unravels complexity to provide assurance for our customers. Whether it is physical assets or the data they feed upon, DNV's experts understand the transformation happening around us. DNV, when trust matters.
Good morning. A very warm welcome here from Oslo to all of you. A very warm welcome to the people present in here. Very warm welcome to the people attending virtually. Welcome to our current series of the breakfast event. For those who are new in here, maybe quickly recap why we organize these kind of things. We, as DNV, want to bring technology and finance closer together. We've got exciting times ahead of us. We all have. We are currently facing a huge task with the energy transition. And we all do play our part. But we also do see that we cannot do it alone. We need to have each other together. Therefore, we want to bring insights to the finance community, with the finance community, and with all the actors and stakeholders involved. Therefore, we organize these kind of events. My name is Martijn Maandag, and I'm your host, your breakfast chairman, as you like, for today. And today's topic is the impact of hydrogen in the industry value chain. I've said I cannot do it alone, but currently I'm still alone at this stage. So I would like to invite my panelists here. In random order, I would like to invite John Barry, Head of Development for Hydro Havrand. Apologies for my pronunciation. Frida Berglund, Consultant and Business Lead, Energy Markets and Strategy from DNV. And from DNB, Aina Kilde-Evanson, Senior Vice President, Industry Specialist, Renewable Energy, Large Corporates at DNB. Also, a special thanks to Aina in helping organizing and hosting the event in which you are here. And also, the energy transition, we also want to do it safely. So for the people in here and for the people at home, please check your emergency exit. But for the people in here, it's just the door where we came through, up through the stairs, in the unlikely event when something happens. But let's not go for that part. We are now at stage with our 4 people. As said, we cannot do it alone. So we very much welcome you, if you've got any questions, to raise your hand or type in to the chat box your questions so that we can discuss that at our table. So it will be a panelist which would like to go into here. To get a bit of a feeling on hydrogen, who from, and you can also type it into the chat box from this audience, already is involved in hydrogen projects? Can you raise your hand? Who wants to be involved in hydrogen projects? That's at least a bit more, but it is an interesting topic. Maybe to kick off and to start, it's good to get a bit of framework. What is the hydrogen market? How it is looking? Therefore, I'd like Frida to kick it off, and maybe before you start, quickly introduce yourself, and then also when Aina and John will get the word, they also will quickly, briefly introduce themselves, and then we've got a nice conversation.
Yeah,
Frida.
Sure. Can you hear me well? Good. So my name is Frida Berglund. I work in DNV in a team called Energy Markets and Strategy. So there we work with a lot of exciting projects, especially on hydrogen, at least that's my field. So I've been asked to just say something about the market to kind of set the scene a bit. And I think, we can all agree that there is definitely a market for hydrogen, otherwise we wouldn't be here today. And there are a lot of different reports published, I would say maybe weekly, about, the new markets or the market outlook, etc. And I would promote our own, of course, market outlook. We have our energy transition outlook, which we publish every year, looking at the forecast for energy systems globally, but also in different regions. And last year, we actually saw that hydrogen is still not scaling fast enough in order to reach the goals that we are set to meet for the Paris targets. But this year, we've been working very intensely on a new report called Hydrogen Forecast to 2050, which is being launched on the 14th of June. So please write that date down. I've been working on it myself, and it's been quite intense, I must say. You know, EU announcing new things every day almost on hydrogen, and yeah, I think it will be very interesting to see the results we've come up with there. I cannot say anything today, but please join us on the 14th of June for that. And yeah, to say that, you know, everything now is happening so fast, but I think, you know, there's still a lot of unanswered questions that I hope we can solve here, or at least try to discuss here today. You know, we see a lot of things announced on producing hydrogen, but of course, what about the demand side? You know, what's happening there? What's happening on policies in the EU? They're announcing, you know, carbon contracts for difference. What's happening here in Norway? I think there's a lot of stuff we need to think about and discuss. And yeah, we were present yesterday on the Norwegian Hydrogen Conference, and there's a lot of interesting debates now ongoing on the speed in Norway on hydrogen compared to other countries. And the main takeaway is that it's not happening fast enough here in Norway. So hopefully we can try to solve that some of that issues.
It's an interesting point. Not fast enough, not scaling enough. Einar, do you share that view from your perspective? Maybe good to quickly introduce yourself as well.
I work in corporate banking side with large clients on renewables and infrastructure. So we work with a number of companies in the Nordic region, also outside of Norway, on hydrogen projects. It's still early, and so none of them have emerged with any firm investment decisions yet. We're waiting for some Enova handouts to come after summer, most likely. But yes, I agree that it's a big market. It's 100 million tons annual on the global level. Using retail price of some dollars per kilo. It's hard to know actually because most of this is not sold externally at all, but it's a several $100 billion market per year. And so and that's basically all of it is with no carbon capture. So if this is to be replaced by green hydrogen, which makes no sense, of course, but hypothetically speaking, you'd be talking several hundred gigawatts of electrolyzers, which is 30 to 50 times the current capacity to produce electrolyzers, and again, hundreds of billions of dollars of necessary investments. As it happens, this is also what it would take to decarbonize the global steel industry, roughly somewhere north of 100 million tons per year, if the steel industry was to convert to green steel. We're seeing some shoots there. But they are very, very big industry. But so far, Russian percentages, as we say, are growing from a very small base.
Maybe to dive a bit deeper before we go to John as well. The trend of decarbonizing is there. The need for green hydrogen, the transfer to that part. Capital is available in the market, but the speed is too low. What is going wrong? Why is it not a match?
Well, because there's limited demand. The value chain is not mature enough. We're working on a number of projects, and what they're all lacking is secure offtake contracts. So if you produce it, who will come? We will certainly see. What we're seeing most of is usage in the maritime sector, ferries, but also offshore service vessels. There's also some initiatives on land-based transport, buses and heavy-duty trucks. but it's still quite low volumes. Yeah, need to get a move on.
That's quite interesting. And then also to move to John, and because you will first start, also quickly introduce yourself. But you already made a decision to develop hydrogen projects. So to some extent, you don't see the problems and the speed where Frida and Arno were talking about.
Yeah, so I just introduced myself. Yeah, my name is John Barry. I'm head of hydrogen development at Norsk Hydro and Hydro's new hydrogen company, Hydro Havrand. Just quickly, just to give some background on Hydro Havrand, it's a developer, owner, and operator of hydrogen plant and infrastructure. And we were formed last year on the back of the capabilities we think that Hydro can bring to the hydrogen market. Hydro has a long history in hydrogen. Some companies like Nel, the OEM, came originally from Hydro. We were a large operator of electrolyzers up until the 1990s. So these were electrolyzers in the 100 megawatt range. So I think we still hold the record for having the largest water electrolysis plants the world has ever seen. That might change this year. But those capabilities are still there, and we've operated electrolyzer pilots in the last decade as well. And I think just from Havrand's perspective, the capabilities of having Hydro as a kind of a big power player, so one of the largest industrial sources of renewable power in the world, operating around 12, 13, 14, depends on the year, terawatt hours of hydropower and wind assets. And then having energy markets in different jurisdictions. It's an important element with respect to developing profitable hydrogen projects. And then on the other side, when we talk about the chicken and egg, you always see the demand side. So Hydro has an internal demand potential of around 4 gigawatts of installed electrolyzer within its portfolio. What's 4 gigawatts? For people who are not familiar, the current German target it might be changing, but the current German target is 5 gigawatts towards 2030. So they're big numbers within Hydro, and we can bring these capabilities to bear. You could even say producing aluminium is quite similar to producing hydrogen. You're taking an electron, you're industrializing it, and you're producing a product. So we have those capabilities to bear. To the question about speed and what's happening, I actually agree with Frida here. The speed from a kind of a deployment perspective and getting this off the ground is not what you would hope. I think there's some big announcements. So back 2 years ago, there was an announcement about the EU and the 40 gigawatt target. So we were looking at 5.6 million tons of hydrogen. More recently, they've now stepped this up to an additional 5 million tons of hydrogen and 10 million tons of hydrogen coming from outside the EU to be imported. You can do some calculations, and there's some variance in it, but you're talking about over 100 gigawatts of electrolyzer to be installed to be able to meet that type of demand by 2030. So I think when the original announcements came out, all of the different individual countries, they really stepped up, and they put in place the hydrogen targets for each individual country, capacity targets. Norway has not put down a capacity target as of yet. But the challenge has been kind of bringing this to an operational sense. So the frameworks are still somewhat immature. So what is the definition of green hydrogen? So there was a big announcement last week on the Delegated Act, and maybe we can talk about that in a while. So what are the operating conditions and the frameworks that you can produce hydrogen, and how do you classify your hydrogen? We're only starting to get some certainty on that now. And then also the deployment of support mechanisms. So whether it's on the CapEx side, so incentives for the actual development of the project itself, but then also on the, let's say, the OpEx side. So, for example, carbon contracts for differences. So there is uncertainty within the projects, and this is very hard to make an investment decision on. So you must remove these uncertainties within the projects if you want to see kind of an opening of the tap on the investment decisions for projects.
That's correct. What you didn't mention was the offtake, and I know you're already developing projects, also on standalone base. How do you deal with?
Yeah, and I think this for me is one of the important points around the whole discussion around hydrogen. So I think that there's a lot of discussion around the production of hydrogen. So big numbers, very interesting. A lot of focus on the hydrogen plant in on itself, and that's very important. But if you have an industrial asset, and let's just say it's you're looking for hydrogen for industrial heat. If you have an industrial asset and you put an electrolyzer outside the door, job done, and walk away. You haven't even completed half the job. You need to prepare the industrial asset to be able to take take hydrogen. So that means going into, in some cases, a brownfield, some cases a greenfield, new development. We're going into a brownfield plant, changing the control systems, changing the plant operating philosophy, changing the fundamental asset, qualifying that actually works, and then also looking at the effect that hydrogen would have, for example, on the product. This takes time. This is quite complicated. So getting hydrogen to a plant doesn't mean it's industrialized. You still need to do the work on the consumption asset side. And I think that's maybe what's missing sometimes from the dialogue. How do we enable and make sure that demand side is ready to take these big, as we say, 20 million tons of hydrogen by 2030. But of course, it's different in different sectors. So you have feedstock, where hydrogen is already used. You could argue, okay, the technology level there is a little bit lower, but the economics might be a bit harder, because normally if they're using gas or converting it to hydrogen already, they're probably at a lower price point. Yeah, so that the economics might be harder, but the technology hurdles might be lower. On the opposite side, in industrial heat, the technology hurdles are probably higher, but then perhaps the fossil fuel molecule that's used in those industrial processes is a fraction of the cost of the product. So you have more flexibility, you have more appetite to take a higher cost of a hydrogen molecule as opposed to a natural gas molecule. So all of these dynamics are very important to kind of just get out and try to have a discussion around them. It's not just production, it's not just midstream and transmission. Demand side is very important, and how do we realize the demand side?
Do you share that view, Frida and Albert, from the projects which you are seeing, that demand side is now currently giving more attention in the framework somehow, or?
Yeah, I would definitely say I agree on that. I mean, especially on, the policies around the demand side. Also, what we saw when we were navigating this landscape for this hydrogen report that I mentioned as well, and what we see in our project is that, on the capex support for producing hydrogen is something that everyone's talking about, and that's kind of given left and right, I would say, or people can argue if that's the case, but still, it's really, how do we really support this change in the demand side? Either it be retrofitting or having this OPEX support, as John mentioned. I think these are very important aspects, and then of course it's the safety side of it as well, which is super important. So yeah, definitely something we need to work on.
I'd just like to add that the demand, sometimes it appears out of thin air, and sometimes it doesn't exist at all. And the magic formula is that you can compete in the open market. Right now, hydrogen's costs are too high to be able to compete directly in the market. And so what you need to do is one of two things: either reduce the cost to a level where it can compete, or you have to increase the price of the alternatives. And that's the dilemma you face when introducing new technologies like that. Of course, increasing the price of existing alternatives will be unpopular for everyone using that option. And so politically, it's a bit of a nut to crack, but at least we have some incentives and subsidies coming now, so we'll get started. And I think the way Statens vegvesen, whatever you call that in English, the government road authority, when they only allocate ferry contracts to zero emission options, that sets the bar for the operator, and they can choose openly between the available options. So it'll be very interesting to see what choices are made with the Vestfjorden ferry.
Yep.
And others.
Yeah, and I agree that it is unpopular to increase prices, because we're already facing increased prices already. So as a consumer, I think we don't like that. When we move to more the capex and opex, you already mentioned, and the frameworks were already mentioned. What kind of certainty, or what kind of topics would you have some more backstop or some more certainty level on to make sure that the level of speed will increase? Assuming that demand will be there. So on demand side, on offtake, we will be bullish. When the hydrogen plant is there will be offtake. So that's covered.
Mm-hmm.
we now look at the capex and the opex, what kind of certainty, what is holding back on that?
Well, you need the distribution systems to be able to transport the material, the hydrogen from where it's produced to where it's needed, which is very often not the same place. And for the producer of hydrogen or the user to take that cost fully onto their own balance sheet, that would very often be prohibitive. So whatever can be done to facilitate a smooth value chain, I think would help tremendously. I'm not an engineer, so I wouldn't even try to explain how to do that, but yeah, leave it to these two.
No, but I agree. I think that's a very interesting part that I've also heard discussions from producers of hydrogen that they say that, okay, for, let's say you want to build an offshore wind turbine. You have of course, need to build a grid, but you have kind of an existing offtake on shore or wherever the offtake is. But with hydrogen, you need to really build that infrastructure and to really put that pressure on the person or the company who is really building out that production unit or the offtaker. You need a total different cooperation here in order to ensure that the value chain is there compared to more traditional industries, I would say.
Yep.
I'd like to go back just one comment you had a moment ago. I think it was very good, Einar. You mentioned that we either have to reduce the cost of hydrogen, or we have to increase the alternative cost, maybe through the ETS system or whatever it might be. There's also another interesting angle as well, that there is a value of decarbonization as well. So you can get a pull from the market. Maybe it's a third way. So when you look at Hydro's portfolio, we have decarbonized products. So there's Redux, a 4.0 product, which is 4 units of CO2 per unit of aluminium, and a Circal product, which is 75% recycled aluminium inside in the metal itself. So it's post-consumer scrap. So the aluminium has gone out to the world, done its job, and come back. These are low carbon products, particularly compared to the averages we see worldwide. So the average carbon content in aluminium worldwide is around 16 units of CO2 per unit of aluminium. So a 4.0 product is vastly decarbonized compared to the global average. And that product in Hydro, it's the sales profile of that. We get kind of two premiums. You get a volume premium, and you also get a price premium associated with that decarbonized product. So the sales profile of that product has gone from it's tripled in the last 2 years, and also on the Circal product, the recycled product, it's also tripled in the last 3 years. And we have a very strong prognosis for those decarbonized products selling more. So there is a pull for decarbonized products. So if you introduce hydrogen and maybe do actually have a certain movement on the product price to the end customer, but there is a willingness to pay if you can demonstrate real decarbonization. And as I mentioned beforehand, it depends a little bit on what sector. We always talk about industry in general. It's very important to talk about how much does hydrogen contribute to the overall cost of product. So if you have a product where fossil fuels are only contributing to 1 or 2% of the final product, and hydrogen, say for example, is double the cost, just as an illustration. Okay, you move the cost of the final product by 1%. If you have a product where hydrogen is half the cost, or where gas is half the cost, then that becomes an issue with respect to hydrogen. So my point is actually on the how can we develop kind of hydrogen? It's yes, reduce hydrogen costs, absolutely increase the cost of fossil fuel alternatives, but also there's a demand pull for decarbonized products, and it's very different for different industries. On the point here on the capex and opex and how we kind of build out the value chain. There's a lot of discussion around getting the hydrogen to the industrial consumption asset. And that's fine in a brownfield sense where you have industry where it's already located. What's also maybe worth considering is does hydrogen follow the industry, or does industry follow the hydrogen? So do you see industry go to where hydrogen is produced at the cheapest rate? So you can say, if you look at the fundamentals of the Nordics, they're quite good. So you have almost a fully decarbonized grid. You have a kind of a low cost of renewable production, very good wind conditions, for example, in Norway, onshore and offshore, some of the best in the world. So fundamentally, the price point of production costs can be quite low, and that's a big contributor to the production cost of hydrogen. Same can be said about South America, Brazil, and Chile, and so forth. So if hydrogen is a large component of your product cost, why do you try to move hydrogen? Because it's quite expensive to move it around. It can be moved, it can be moved, but the cost implications are quite high. So then do you see new industry as it's developed moving to sectors or jurisdictions where the hydrogen is actually cheap? Now, that's a very interesting debate. So in Norway, you'd say, is there a potential then to bring new green industry to the Nordics in order that they get the best price point? And you can say fundamentally our smelters in Norway are a similar situation. Smelters are located in Norway. We export a lot of the aluminium to mainland Europe. Because of course we have the grid, and we have a renewable grid, and competitive in most jurisdictions, competitive most of the time power prices. So I think that's an interesting discussion, that you can actually also bring the industry to the hydrogen.
So basically, you then use hydrogen as a market maker.
Yes.
So saying, well, we produce, and the industry will follow to the place where the hydrogen is the cheapest.
That's one component of it.
Yeah.
And there's other components where you will still have industry. So for example, in Europe, and they have a huge demand for hydrogen. So who can step up and deliver that 10 million tons that they expect to get from outside Europe to Europe? And of course, you always hear about Chile and you hear about Australia, but you kind of go, when you look at the fundamentals, maybe Norway's in a very good position, and Sweden in a similar position. And given the development of some frameworks in the last week or two, the position looks even stronger.
Yep.
So this is an interesting time to be in the Nordics with respect to hydrogen.
Maybe quickly check in on the panel there as well, with the development of the frameworks and having hydrogen as a pool. Is that something which you see as well?
I definitely think it's a very interesting comment. I must say I haven't seen it in my own eyes that industry is moving here, but I think it's definitely an option. And with regards to the competitive position for Norway, with this, as John mentioned earlier, the delegated act, now saying that if you have a grid mix with 90% renewables, then you can produce hydrogen and label it green from the grid. And that puts Norway in a huge advantage compared to other countries for producing green hydrogen and for use, of course, at home, but also for exporting it to Europe and having that certificate ready. So I think that's a very interesting position for Norway.
I guess the total ability of a community to attract industry depends on its total mix of input costs. Hydrogen being one thing, and the electricity and labor, skilled labor. Yes, cheap and abundant hydrogen would certainly help to attract new industry, but it would not necessarily be enough. It's costly to transport hydrogen from Norway to the continent. We're talking 1,000 to 2,000 kilometers, or even 3 if you're from Finnmark. And so the cost would be, from what I've seen, $1 to $2 per 1,000 kilometers. Of course, it's a big calculation, basically taking the total capex of the pipeline and divided by 30 years of transportation. So lots of assumptions there, but yes, cheap and abundant hydrogen would help, but it's not enough.
What additional things do you need then for the
Well, as I said, skilled labor and being competitive, and also the road to market for the finished product. If that's also something that's expensive to transport, then maybe it would make sense to have the industrial facility closer to its market.
In terms of facilitating or increasing, what kind of incentives would help, or what might be possible to?
Well, from a bank perspective, what we appreciate is low risk. So whatever helps the company reduce its risk, that's on offtake particularly. We need to be sure that our debtor is able to generate capital, cash flow to service its debt. And then if they have that in order, then their input costs, how variable are they? So if they can fix those as well, then you have something which resembles infrastructure asset, which just has a fixed markup and guaranteed volumes. If it's not built yet, of course, you need to look at the risk of construction. I think those are the main three risks.
Yep. What I don't hear you say is the level of maturity of the technology. So does it mean that there's already a certain acceptance that will, of course you need to check it, of course you need to design it properly, but in the end that's already reached a level of maturity that you will say, well, we're comfortable on doing this?
It's somehow in there because nobody will buy or sign a fixed contract for many years ahead on a technology which is new. So I think that's I didn't specify it, but it's certainly there. We don't give multi-year loans to unproven technologies. We don't do that.
No, that's understandable. But is the hydrogen then still in the unproven part or already in the proven part?
Hydrogen is proven. We don't have any problems with hydrogen, as Barry said here. You've been doing it for 100 years or more, so that's enough for us.
And I think you just highlight on that. It's So the technology, from an alkaline electrolyzer point of view, say for example, that technology is proven and it runs, and there's an understanding of the degradation, for example. But people conflate that sometimes with the scale. So actually, scale will drive down costs. So these are the learning curves. So as we deploy this, we'll start to see manufacturing processes improve, and we'll drive down costs as well. But from a technology perspective, I think it's something that obviously still needs to be managed from a risk perspective. So you can say it's not just the electrolyzer. There is the entire balance of plant that goes around that. There is also immaturity with respect to how the electrolyzer plant interacts with the power market. There's a lot of value there if you're able to leverage that capability. And that can be designing the electrolyzer to a larger effect to be able to play the curve, even if you have a PPA. And then there's also some uncertainty and risk that needs to be managed on the demand side, on the industrial consumption side as well. So that's where a lot of the development now is, to be able to introduce hydrogen into the consumption assets.
Yep. Yeah, we still keep going back in the end to the offtake, but you also said on technology part the learning curves and scale and drive down cost. Frida, you mentioned you've worked on a report, which you're not allowed to disclose yet. So I won't put you on the spot, but still will ask you, what is your opinion on the cost development and learning curves in that part?
Yeah, I cannot disclose anything, but this is of course not. I mean, the learning curves for electrolyzers is definitely something we're investigating, and it really comes down to how quickly you can scale it and scale up to size. And I think that's still something that's in the unknown, how fast this will go. But definitely there is a large cost reduction potential, but also some potential for increasing the efficiencies as well in this technology that is still a more unproven level. So I think there's definitely things happening here that can reduce the capex and also the opex costs. And we also, yesterday there was very interesting talks with Norwegian companies who are now working on very efficient electrolyzers, for example. There's definitely stuff happening there, and that's something we need to follow more closely.
Okay. And the cost development, will the same be like other technologies, like we have seen with offshore wind and potentially will see with floating offshore or floating solar? Will it the same pace? Does it need to have some more incentives from government or elsewhere perspective?
I would say that what we found in our ETO last year was that we need policies that are similar to what has been on the renewable side in order to scale and reduce the cost. What exactly that is difficult to say, but these types of policy incentives as well as scaling. If it will happen in the same tempo, I'm not sure, but Do you have a comment there?
I think it's a very good point at the end. It's similar, but there are some nuances. So I think on the electrolyzer plant itself, you will start to see scale effects, and you'll see efficiency improvements, and that even just comes from the manufacturing processes themselves. But you also have the balance of plant, and you have the civil works associated with that. Yep. And of course, then the scale then helps you to reduce the per capita kind of cost associated with that. So we will see good dropping on the plant, but the balance of plant, more conventional technology that supports the electrolyzer plant and the civil works, you won't see the same level of dropping on that. But towards 2030, still a substantial drop, but not to the same extent, I would say, in general as wind and solar.
Yeah, I can just add that you have to keep in mind that while reducing capex is great, the main cost for producing hydrogen is the electricity. You're talking, it depends on the price of your electricity, of course, but potentially 70–80% of the hydrogen cost is the electricity. So reducing capex is reducing a small share of a small but a very important share of the total cost. Now, what kind of electricity are you going to use to run your electrolyzer for green hydrogen? That's going to be renewables, right?
Yes.
So the cost of the falling cost of renewables is very important for the cost of green hydrogen. And of course, we probably shouldn't go into that variable intermittent power discussion right here, but a wind park, or offshore wind park, may have 50% load factor, 4,000 some hours per year. If you run your electrolyzer only for 1,000 hours per year, that's going to come out in very high unit costs because you divide the capex on too few kilos of produced hydrogen. So, is hydrogen going to be a load balancing factor in the grid of the future, which will have much more intermittent power, or is it going to be a base load factor? That's also a key question.
Frida, you want to add something?
Yeah, no, it's just important what you say here. I think also for people in the audience or anyone who wants to, start a project on hydrogen, I think it's important to understand that there are, different aspects you need to think about depending on your project. So for an electrolyzer, it's not just an electrolyzer, right? You can, as Einar mentioned, if you have a renewable-based project, you would have low load hours. So then, the capex of your electrolyzer is super important. And of course of the renewables as well. But then if you're connected to the grid, then the electricity cost is more important. And the efficiency of the electrolyzer using less energy is more important than the capex part. So just thinking about that when you look into, what electrolyzer do I buy maybe in the future, it's important to have that in mind.
And I think you can segment it out over time. I think when the capex is what it is now, a little bit higher, back to Einar's point, you want to get as much utilization out of it as possible. Yeah. I think we start moving towards 2040, 2050s, and the capex has come down dramatically. You don't need to spread that capital over the unit cost of hydrogen, so you're much more likely to have kind of more intermittent type relationship with the power generation. But even if you look at the delegated act as it's written now. You alluded to it as well. If you're in a price zone where you have 90% renewables in a bidding zone, then you can operate your electrolyzer and classify it as green. But you can still only operate the electrolyzer to the representative grid mix. So if it's 92, you can only operate it 92% of the time. If you're in mainland Europe and you don't actually have that grid mix, then you're in a situation where you have the additionality principle, which must be done. So basically the wind power plant or the renewable power plant must be developed within 3 years of your electrolyzer, and that's a tough requirement. And then also you must produce in a temporal, so kind of an hour by hour basis, based on the production of that plant. So that they are very tough requirements in mainland Europe now for potentially for producing hydrogen. In the Nordics, Sweden and Norway, in certain bidding zones, we don't have to necessarily meet those type of requirements. So it gives us a very strong advantage compared to our European partners and friends. It's also worth mentioning that you must get the renewable power from wind farms that are or solar farms that are not subsidized as well. So additional requirements on the production of hydrogen. So there are tough requirements for the production of hydrogen in Europe, and the Norway and some of the bidding zones in Sweden will not necessarily have to meet those type of requirements to classify their hydrogen as green.
It's an interesting statement what you are making. We also see in the market there are a lot of investments in developers, and with all the development pipelines, the renewables developers, I think without any exceptions, they're also thinking of putting hydrogen next to their renewable plants, either for curtailment or for other things. You already made development decisions. What is the load factor, what you are calculating them with? What do you think?
That's very specific. Yeah,
42.
No. So we have a portfolio of projects in our pipeline, mainly around the Atlantic basin. So in the Nordics, so in Sweden and in Norway, mainland Europe, and also in South America, in Brazil. And when we're looking at the projects and how you optimize the projects to get the lowest unit cost of hydrogen, you take all these factors into account. A big factor is the point that Einar raised. With the capex that we're seeing for development, say for example in the Nordics, with the costs associated with civil works, balance of plant, the actual electrolyzer itself, delivering to the industrial plant, utilization is extremely important. So you're looking for more of a kind of a baseload type demand and highest utilization as possible in general. Yeah, and then there's ways to optimize around that. It's a little bit like the smelter portfolio. It's never in balance. You can do a lot of market operations to optimize the unit cost of power to the electrolyzer plant.
Okay. Do you see the same from your perspective, or do we also need to think in load factor you might establish now, but increasing time as renewable developments will also increase, so the generation mix overall, let's say, will increase in every country, in every region?
There will certainly be a development there. I agree. Most of the projects we see are targeting very low utilization. But I think it's very important to be aware of this, because also the hydrogen business and many players are very vocal about hydrogen's ability to be a load balancing factor, while also assuming 8,760 operating hours per year, and that doesn't necessarily go together.
No.
So in order to reach those cost targets that they set, so you have to choose one or the other.
I see one question from the audience. Yes. Wait one moment. There's coming a microphone so that all the people at home also can hear you.
Very interesting. One topic has not... My name is Jarl Hammer. I've been research director of Fernley's Shipbrokers for many years. One topic, what about the risk of transportation and storage? It hasn't really been a success to run hydrogen-fueled cars in Norway. There's a very, very big difference between gas form and liquid form. In LNG shipping, we haven't seen much accidents at all. What about the risk here? We have seen that something has happened in small-scale storage.
I can start. Very good question. It's good to talk about the maritime sector a little bit more. I think the maritime sector is going to be very interesting from a hydrogen perspective. I think to compare it to cars, for example, using hydrogen. Use hydrogen where it makes sense, I think is a message. So if electrification, so battery vehicles make more sense, you should use it. But where you have kind of high load, kind of heavy industrial type work for very long hours, then hydrogen could make sense. So we think about heavy trucks in particular, and we can talk about where's the cutoff between electric trucks and potentially hydrogen trucks. But a lot of the trucking actors are moving into hydrogen now. I think, like you say, cars don't necessarily make sense because battery does a very good job in that area. In shipping, Shipping is interesting, both from a safety perspective, but also from a kind of an economics perspective, and the discussion around what is the hydrogen vector of choice. So you can talk about, when you say safety, are you talking about liquid hydrogen? Are you talking, which is challenging? You know, it's the second coldest element on the Earth, over minus 250 degrees. Are you talking about compressed hydrogen, which still, from a volumetric perspective, takes up a lot of room? And then you can look at the derivatives. So you're looking at, for example, e-methanol or potentially ammonia. And they all have very different safety characteristics, and they all have different price points. So there's different suitabilities for different areas in the shipping sector. So for short sea shipping, compressed hydrogen could make a lot of sense. For more ocean-going type shipping, I think then you're discussing e-methanol or ammonia, and they all have different safety challenges associated with them.
I can just add that the safety aspect is extremely important to DNV, and it was quite extensively discussed yesterday on the hydrogen conference, because you have something called a social license to operate, and I think if you do have an accident by any player, it could be the worst performing player of the industry who has some sort of a blow up accident, that will affect the entire industry. So it's important that the regulators are strict and transparent, so that the public's trust in hydrogen is not affected when there are accidents. So yeah, this needs to be taken very seriously.
Yeah, yeah. We don't want to experience what you see in the nuclear sector, for example.
No,
with those big kind of accidents.
That's a whole big topic, but I think nuclear is one of the safest forms of energy that we have on the planet, but still so many people are very skeptical about nuclear.
Yeah,
which is a shame, actually.
Yeah, no, true. We've got another question from the audience. It's over there.
Yeah, my name is Herbert Christoffersen from the Ministry of Finance. Thank you for interesting points. And obviously, our ministry is very keen on seeing that hydrogen might have a way of reaching the very difficult ways of reducing emissions. However, we are obviously very interested in seeing that we reach our targets without unnecessary high costs. And I see, according to International Energy Agency from last year, they stated that while grey hydrogen that is producing from gas is about maybe 50% more expensive than without taking out the CO2. And then electrolyzer production, green hydrogen, might be maybe 4 times the price of grey hydrogen. And in your panel seem to be very mostly focused on the option from producing green hydrogen. And what are the options of reducing the costs? You mentioned that there are options to reducing costs, but I guess that will also be the case for blue hydrogen. Why is there any chance that that the cost of green hydrogen might be in the region of blue hydrogen in the future? Thank you.
I can maybe comment quickly on that. Very good question, and very important question as well. I think what's important to know is that, now we see a very, with all the developments now and the war and the high energy prices and the high gas prices, not to mention those, we actually see that, green hydrogen or renewable-based hydrogen, or whatever you want to call it, can actually be produced at lower costs, where you have very good renewable conditions. So, for example, that's one of the discussions we're now also having in some of our projects is whether it makes sense to produce blue hydrogen today with the gas crisis going on now, and Europe needing all natural gas, in the short and medium term. So I think to your question, yes, I think green hydrogen can definitely come down to the cost of blue, but it depends on where you produce it. You need low-cost renewables. And blue is very much dependent on the gas price and of course the value chain cost of CCS, but mostly the gas price. And to that extent, you need really these stranded gas assets in order to have an economic case for blue hydrogen. And well, that's not really the case right now, at least in the short term. So yeah, I don't know if that answered your question, but maybe you want to...
I can also add that the cost of producing green hydrogen it can be already quite competitive. We're talking costs down to €2 per kilo and factory gate costs, like in northern Norway, where power is almost for free. If you build exactly the same electrolyzer in southern Norway, you're talking 8 to 10 euros per kilo factory gate. And so obviously what are you going to do with the hydrogen when it's in a small valley in the northern Norway? You need to transport it to where it's going to be consumed. And also it begs the question, what are we actually going to do with the cheap electricity we have now in northern Norway? There's so many different projects, not only hydrogen, but also data centers and various other types of projects. So I think we need to have an educated discussion about those scarce resources also, and not only capital, to be continued.
Yep.
Yes.
No, thanks a lot. I think that that's good. We have discussed of course, we have not discussed everything for the hydrogen projects, but we have touched upon some various points. Einar, following this discussion, what would be your key takeaway which you want to give the audience when we close this session and we walk out the room? What do they need to remember on the hydrogen?
That DNV has a lot of appetite to support companies in hydrogen and renewables and infrastructure, but we need projects and companies with cash flow that can serve the debt. So yeah, if you have a viable project, you know who to call.
Let's talk afterwards.
No, that's definitely good, and of course there will be some technical and market advice. Therefore, we also know somebody who to call. But Frida, what would be your key takeaway?
Yeah, call us. No, definitely. I mean, there's still a lot of unanswered questions, I would say, and with the current situations, that begs even more questions. So, yeah, definitely, of course, call us if you have questions about where the market is going, or of course technology qualifications and risks. But to be jokes aside, I mean. I think one of the key takeaways to remember today is that things are moving fast, but we still need to speed up in Norway if we want to kind of get on this train, as they say, and that's very important to remember. And yes, things take time, but to just sit and wait for something to happen, wait for the perfect time to act. I think just go ahead and start and yeah, I guess that's my key takeaway.
That's a good takeaway. Go ahead and start. John, you already started.
Yes, we started, and but I want to echo some of the points that Frida was saying. I think the speed is important. I think Norway is in a fantastic position, from a techno-economic perspective. So the potentials are there. We have a very good potential demand area in Europe, so that's very exciting, and the frameworks look to be in our favor. I think Norway has one of the best R&D environments in and around the energy sector. I think now just to start to speed up the deployment of these incentives, be them CapEx or be them kind of OpEx in CFDs, will be very important for us to be able to capitalize on this opportunity for delivering hydrogen to Europe, potentially, to decarbonising Norway, but also to bring new green industry to Norway. I think it's very exciting, the position we're in, so we should try to move fast and capture that value.
Yeah. No, thanks a lot. I think, so a bit to summarize it, we are moving fast, but not fast enough. We need to do even faster. Technology is there. We've got views on how the CapEx and OpEx potentially can, with the learning curves, the scaling can be more beneficial for the hydrogen projects, even on standalone. It's still the topic, important topic of safety, still the important topic of the offtake, which we have not yet solved. It was also not expectation to solve, but to some extent I like a bit of the bullish part. Let's organize it and the industry will follow. But that takes, is it leadership? Is it guts? I don't know. And let's focus on that part, to really having this interesting technology like hydrogen supporting the decarbonization trend as well, because we do need it and we do foresee that. Having said that, I really want to thank all of you in being present here, being present at home and listening in. I also would like to emphasize, like Frida already did, our upcoming Hydrogen of the Future event. So that will be the release of the report. For the people in here, first time we do this from Oslo, very warm welcome. And I would like to invite you outside this room for have another cup of coffee and some snacks. For the people at home, I also would like to invite you to have a cup of coffee and some snacks. Unfortunately, we cannot bring it to you, but nevertheless, please use it. A lot thank you. Our next event will be hosted from Germany. But first, enjoy also the annual leave and the summer period. A lot of thanks, and hopefully our paths keep crossing, and hopefully we keep connecting and discussing together. We cannot do it on our own. We all need to play our part, and communication is one of those key items, because in the end we want to tackle the energy transition and bring finance and technology together. Thanks a lot, and thanks a lot for the speakers, John, Frida, and Arnar, and special thanks Arnar and DNV for hosting, and the venue, the lovely venue in here. And we're looking forward to our next event. Thanks a lot.